All right, Hess's law. For every process that occurs in a series of steps, the overall heat change is the sum of the heat changes of the steps. Okay, that might sound a little bit hard, but you know this already. I'm going to take my day as an example. So I got up this morning, had some cereal with milk, 400 calories-ish, okay? Rode my bike to work, burned 100, got to work, ate a banana, added another 100. For the last couple hours, probably have been running around, walking, breathing, whatever. And just by doing that, burning another 300-ish, whatever, right? So at this point, that means that I am plus 100 calories. So if I don't want to be gaining weight, I better tone down the eating for the rest of the day, right? Because the more plus I am, the more weight my body's going to gain. So I either need to eat less or exercise more. My overall heat change at this point is the sum of the heat changes of the steps in my day. Let's look at that in what a question. So here's an IB question. Calculate the heat change for this reaction here using the reactions below. So this is a puzzle. I've got two equations and I'm trying to add them together to get my goal equation here and find the overall heat change. So both of these things are happening and these heat changes are happening, but it's this one that I care about. Let me show you what I mean. So we'll look at this equation first, the first one, and we're going to find, first question you ask yourself is, what is in my goal equation and in this equation, but not in the one below? So NH3 is in the one below, not going to work. O2 is in the one below, not going to work. N2, though, is in my goal equation, but not in the one below. So we're going to focus on that. Now we're going to ask ourselves two questions about the N2. First question is it on the correct side of the equation? No. So I am going to have to flip this one. Second question I'm going to ask myself is there the correct number of them? No. So I'm going to have to divide it by 2. Let me show you what that looks like down here. So I'm going to put the products on the reactant side and divide each thing by 2. So instead of 2N2, I've got 1. Instead of 6H2O, I've got 3. And I'm going to do the same on the other side. And I know that 3 halves O2 might look weird, but bear with me. You can put 1.5 if it makes you feel better. And then I'm going to do the same with the heat. So instead of negative, it's positive because I flipped it. And then I'm going to divide that by 2 as well. All right. Let's try it with the next one. So this one right here, I'm going to ask the same questions. What's up here in my goal equation, but not in this one? So not NH3, not O2. Hey, NO. There it is in my goal equation. So I'm going to focus on it. Next two questions. Is it on the right side of the equation? Yes, this time. Is it the correct number? No. So I need to divide by 2 again. I'll do that down here. So I have 2NH3 plus 5 halves O2, and that makes 2NO and 3H2O. And then I'm doing the same with my heat, dividing it by 2. Awesome. All right. So if I did it right, I should be able to add those together, and it should end up being my goal equation. So, the NH3 is canceled. That's nice. The H2O is canceled. That's nice. So I've got N2, just dropping it down. I've got NO, so I'm going to drop that down. And let's look at these O2s. So I've got 3 halves and 5 halves. I can cancel this one and make that a 2. So 5 minus 3 is 2, and I get just plus O2, or 2 halves O2, which is the same thing. Now if you do the same with your heat changes, you end up with, I think it's plus 180. And so this process occurs and absorbs heat, then this process occurs and releases heat. Overall, we've got a heat change of plus 180 kilojoules. Awesome. All right, let's try another one. So with this one, we've also got a goal equation, and now we've got 3 equations to add together. So we ask ourselves, look at this one first, ask ourselves the questions. What's in this equation, but not, and this one, my goal 1, but not in the ones below? Well, it looks like C2H2. So I'm going to focus on that and ask myself, is it on the right side of the equation? No. So this one I am going to have to flip. Do I have the right number of them? Yes. So I'm not going to rewrite it this time. Too lazy for that. So I'm just going to write the heat changes, because that's all we really care about in the end. Okay. So let's look at the next one. So we look at this and we say, what's up here in our goal equation and not in the others? Well, carbon. Okay. So is it on the correct side? Yes. Is there the correct number? No. I'm going to have to multiply by 2 this time. So all right. And then same with the last one. H2 is in my goal equation, but not in the others. Is it on the correct side? Yes. Is there the correct number? Yes. And so we do not have to change this one at all. And so negative 285.8. If you add all those together, what do you get? Oh, I don't know. 1299.6. Should get positive 226.8 kilojoules. Don't forget your units. Awesome. So we put our puzzle together, and we got this equation by adding together the others. Hess's law. So your chance to practice. This is what the worksheet looks like that's in your packet. There's Hess right there. What a nice looking guy he is. Yeah. And so you're going to do the same here. I didn't leave you a lot of room to rewrite them, but you can still do it without rewriting it or on another piece of paper. All right? Good luck.